All right, guys. So today I'm going to be showing you the chi-square lab quiz. The chi-square analysis is really interesting because it's a unique way to look at essentially the association between categorical variables. I know I've stressed in the past that it would be meaningless to put gender into like a Pearson's R correlational analysis because those are quantitative variables. You can't do it. Something like the t-test or the ANOVA, you can look at the relationship between one categorical variable and a quantitative outcome. But what if you're interested in the relationship between two categorical variables? You can do that quite easily using your chi-square. So in terms of different kinds of chi-square, there's degrees of complexity. The more simple chi-square is what we call the one-way chi-square or goodness of fit test. This is when you're evaluating frequencies in different categories, and essentially you're just interested if any one of the categories has like a higher frequency than the others. So for this particular data set, it's a sample of 30 hypothetical participants, and the variables include major, political identification, and gender. So to orient you to the data set, and this is particularly relevant now that we're at the data analysis stage, and I've been helping a lot of you put together your data set. If we're dealing with categorical variables, it is always worth your time to create those value labels. So the data in SPSS is always inherently quantitative, or typically quantitative if you want to do an analysis. So this strings of 1s, 2s, and 3s, we want to make them mean something in terms of what does a 1 mean, what does a 2 mean. So you create these value labels here in the value column on the variable of interest. You create a numerical value and you give it a label. So for example, group 1 is the psychology major group. So since these are all categorical variables currently under consideration, I did the same for the gender variable and for the political identification variable. Okay, so back to our data itself. First, we're going to conduct a goodness of fit test on all 3 of the variables of interest. What is the chi-square value and p-value for these 3 variables? The chi-square is subject to the same hypothesis testing framework that we've seen before. We obtain a statistical outcome, in this case, a chi-square value, that we evaluate for significance. So there's a statistical outcome and its associated p-value that we use to evaluate for significance. So here's how we run our one-way chi-square. It's kind of hard to find. Analyze, non-parametric tests, legacy dialogues. I don't know what legacy dialogues mean. I've never asked. Jesus. Oh my God. Hold on. Why is it like this? Non-parametric, legacy. There we go. Chi-square. Okay, so we can put as many variables into our chi-square at once that we want. It's going to spit out 3 different chi-square outcomes. We're going to leave this all categories equal option selected. Essentially, in your one-way chi-square, you're going to be evaluating obtained frequencies against expected frequencies. So unless otherwise stated, we're going to be evaluating our obtained frequencies against the null hypothesis of all of the category counts being equal. We're going to leave that the way it is for now. And our results, right? We have the actual frequencies. So the chi-square evaluates observed frequencies against expected. If the null hypothesis is that there will be equal counts per category, right? You see that there's an equal expected N in all 3 of your levels, for major, gender, and polyd all. But your observed frequencies, they differ. So the idea is, if we are evaluating whether or not one of these groups has a higher frequency count, we're going to be comparing these actual frequencies against that null hypothesis of the categories being equal. So to what extent do these observed frequencies deviate from those expected frequencies? The chi-square actually evaluates this for significance. So your chi-square values are down here at the bottom. Your chi-square for major is here in this first column. This value in the first row labeled chi-square, that's your obtained statistical outcome. That's your obtained chi-square. This row labeled asymptotic significance is your p-value. So the One-way chi-square for major has a chi-square of 6.2 and a p of 0.045. So that's less than p equals 0.05, so that's significant. To interpret a significant chi-square, you can return to the observed versus expected frequencies to evaluate what drove that chi-square to significance. So the biggest difference from observed to expected here in the major variable is an overrepresentation of psychology majors and a slightly relatively less of an underrepresentation of criminal justice majors in our particular sample. So the significant chi-square tells you that people are more likely to be psych majors than criminal justice majors. For gender, that is a chi-square of 8.6 and a p of 0.014. So this gender variable, if we indicate that we're expecting an equal number of people to identify as female, male, or other, then our chi-square is significant. In this case, there's an overrepresentation of women, given that it's a hypothetical sample of psych majors. That's not maybe particularly surprising, and an underrepresentation of people who self-identify as other. Now, if we're evaluating against equal expected frequencies in all these categories, yes, our observed do deviate from expected. In the next example, though, we're going to use a more expected gender breakdown, right? Most people affiliate as male or female, so we're not necessarily going to expect equal n's or sample sizes in these three different groups, but at present, that chi-square is significant, indicating, again, an overrepresentation of women and underrepresentation of other. This last chi-square for political identification, chi-square 1.8, p-value of 0.407, so that's not significant. So despite the fact that there is some deviation from observed to expected in the political identification, these differences are small enough that they do not drive our chi-square to significant. The political breakdown in this particular sample is roughly equal. Not perfectly equal, but the chi-square being non-significant tells us that they're not different enough to be meaningful. So that was our first one-way chi-square. We're now going to reanalyze the goodness of fit for gender, because like I said, based on demographic breakdowns, you wouldn't necessarily expect there to be a completely equal breakdown of men, women, and other in a sample of undergraduates. We know that the sample for psychology majors skews female, and that people who self-identify as other make up a smaller percentage of the population. So we're going to reanalyze the goodness of fit for gender, taking into account that we expect basic demographic breakdowns for gender to be sort of inherently different in those various groups. So we're going to reflect that in our expected frequencies. So we're going to reanalyze goodness of fit. And in this case, we're going to tell SPSS that we do not expect all categories to have equal frequencies. We're going to enter expected for female to be 13, for male to be 12, and other to be 5. Typically, you can't run a chi-square with an expected frequency that is less than 5. So now back to our non-parametric tests, back to legacy dialogues. Chi-square. So we can get rid of the other variables because we're not going to run another analysis on them. So as opposed to letting all category expected values being equal, we're going to enter in the values that we expect. We're just going to enter the numerical values in the order that the groups are coded. So female is coded as group 1, so that's going to be the first expected frequency we add. Males are coded as 2, so we're going to enter that one next. And other is coded as the third group. So the third value we enter is going to be the expected frequency for the other category. From there, we rerun our goodness of fit test. And what we now see, when we chart our observed or obtained frequencies against these inherently not equal expected frequencies, we see that that chi-square is no longer significant. So what this tells us, as opposed to the first chi-square, is that our obtained frequencies do not differ from what we would expect. So as opposed to our quote unquote expectation being equal counts per group, we're evaluating our obtained frequencies against the inherently disproportionate demographic breakdown for this variable. So yes, there are more women than other, but this sample roughly maps onto the demographic breakdowns that we might expect. So in this case, the observed frequencies do not differ significantly from expected, as noted by the chi-square that is much smaller, that has dropped to non-significant. So P of 0.455 is greater than 0.05 and as such is non-significant. So then we're lastly going to run our tests of independence, otherwise called a two-way chi-square, on all possible combination of our variables. So like I said, a chi-square will let you look at the association between categorical variables. So gender and major, this essentially will let us evaluate whether or not there's a relationship between gender and major, such that, for example, maybe more women end up being psych majors. So it's not that we necessarily care that there's more women than men in the sample. It's does gender have an effect on major choice? So that's what a two-way chi-square tells you as opposed to a one-way chi-square. It's about the extent to which the categorical variables interact with one another. We're going to conduct a series of tests of independence on all possible combinations of our variables. Let's start with gender and major. The two-way chi-square is pretty hard to find, pretty counterintuitive to find, not that hard. But it's actually in descriptive statistics, and you go to crosstabs. So cross-tabulated data is essentially a way to visualize your frequencies that maps out the breakdown based on combinations of your groupings. So whereas a regular frequency distribution would just show you how many majors there are in different categories and how many men versus women versus other there were, a cross-tabulated frequency distribution is going to show you how many women were psych majors, how many men were psych majors, so on and so forth. So the first chi-square for gender and major, you're going to put one of the variables in row and the other in column. So if we were to stop here, it would just show us a cross-tabulated frequency breakdown. To run an actual chi-square, you select statistics and you hit chi-square. Like I said, it's not the most intuitive place for an inferential two-way chi-square test. So from there, we hit OK. What we see is first our cross-tabulated data. So again, it breaks down the frequencies by combination of variables. So how many women were psych majors? How many men were psych majors? So on and so forth. So again, this is distinct from the one-way chi-square because we at this point do not care that there were more psych majors than any other. We only care if women were overrepresented as psych majors. So it's about proportional breakdown and whether or not the two categorical variables impact each other in some way. So the result for your two-way chi-square is listed down here. The value in the value column in the Pearson chi-square row, that's your obtained chi-square. So the obtained chi-square for the relationship between major and gender of 4.841, the p-value here in the asymptotic significance column of 0.304. This tells you that there is not a significant relationship between major and gender. Again, the one-way chi-square for gender and for major on their own were significant. There's more women than anyone else. There's more psych majors than anyone else. The two-way chi-square answers a question that is quite distinct. It's whether or not major and gender interact. So if, for example, women were far more likely to fall into this psychology group, or men were far more likely to fall into the criminal justice group, that's what the two-way chi-square tells us. What this tells us is that there's a roughly proportional amount of men, women, and other falling into these three categories, right? So there's more women in the psych category, but that's just because there were more women overall. These breakdowns are roughly proportional to how many women, men, and other there were in the sample. So again, a non-significant two-way chi-square tells us that major and gender are not impacting each other. Okay, so we're going to do all possible combinations. So gender and major. Now we're going to do gender and political identification. Gender and political identification. Again, chi-square should still be selected if you don't change anything. Which one you put in row and which one you put in column will just impact the orientation of your cross-tabulated frequency table, but it does not impact the actual chi-square computation. So if you have these reversed, you should get the same result. Again, we see the breakdown of how many women were liberal, how many women were moderate, how many people were conservative. Okay, so in the case of this particular chi-square, right, we know from the one-way that there was a roughly equal breakdown of liberal, moderate, and conservative. We know that there were more women in the sample. So the fact that we see different values here in each cell of the crosstabs, right, is a reflection of the fact that there's more women overall. So just because there's more women in the liberal category than men in the liberal category doesn't mean that gender is impacting political identification, because again, there were more women overall. So the question of the two-way chi-square is, again, does gender impact political identification? Are women more likely to affiliate as liberal? Are men more likely to affiliate as moderate? Whatever it may be. Once again, upon evaluating the chi-square value of 3.147, a p-value of 0.534, that chi-square is again non-significant, which tells us that there is not a significant relationship between political identification and gender. There's a roughly equal gender breakdown among the different political affiliation groups. Okay, then lastly, between major and political identification. All right, so once again, we have our cross-tabulated data and our chi-square test. This one, on the other hand, we can see that the obtained chi-square is much higher at 14.818 with a quite small p-value of 0.005. So that's less than 0.05, so that's a significant two-way chi-square. Again, what this tells us is not whether there were more moderates than anyone else, not whether there were more psych majors than anyone else. It tells us whether or not political identification and major are interacting in some way. So to interpret why we have a significant chi-square, you basically just want to go back and eyeball the crosstabs. Do any one of these groups, any one of these particular cells representing a particular combination of your categories seem out of step, appear larger or much smaller than any of the others? What stands out to me upon looking at the cross-tabulated data is that there's a ton of moderate psych majors. That one appears a lot higher than you might expect. So, based on the fact that this appears to deviate the most from what you would have expected, likely the driver of this significant chi-square is that psych majors are much more likely to be conservative. And additionally, you see that this cell appears a bit out of step as well. Someone in the criminal justice major appears much more likely to fall under the conservative label. So again, when you have a significant two-way chi-square, it becomes a matter of asking yourself, how do these two categorical variables appear to be impacting each other? So when you have a significant two-way chi-square, we say that the variables are dependent on one another, meaning that when the two categorical variables are combined, we see that some of these particular cells or combinations of these levels appears to deviate from what you would have expected. Okay, so those are all the questions for your chi-square lab quiz. Like I said, it's a pretty easy one, but it can be a little bit tricky to find the chi-square in the drop-down menus, but that basically does it for your chi-square lab quiz. So at this point, I'm going to end the recording and take any questions that you may have.